All right, so let's start our first example using our central limit theorem. So we're going to use the kind of that list of steps that we saw on the previous page, where we're going to check our conditions, we're going to find our normal distribution, and then find our probability. Before we do that, we're just going to kind of organize our information here. So up at the top we have our problem. According to the Mars Company, packages of M&Ms contain 20% orange candies. Suppose we examine 100 random candies. Find the probability that our sample will contain 24% or more orange candies. So what we're going to start by listing is we're going to start by listing out things that we know and what we want to know. So N, remember our capital N is our population. So our population is going to be all M&M candies. Right, our lowercase n is our sample. And in our sample, there are 100 random candies. P is our population proportion. So this is 20%, which we are going to write as a decimal, 0.20. So this lowercase p here, again, this is our population, this is our sample size, this here is our population proportion. Okay. All right, what do we want to know? Well, we are told to find our probability that our sample will contain 24% or more orange candies. So the reason I'm kind of marking this p, so this lowercase p all by itself is our population proportion. A capital P stands for a probability, right? So what we're looking for here is we are looking for a probability. Right? And we are looking for a probability that our sample proportion is p hat, right? Contains 24% or more orange candies. So we're going to say is greater than or equal to 0.24. Right? So we have 3 different p's in this problem, and they all mean different things. Our plain p is our population proportion. Right? This capital P out front here is our probability, and this p hat that we see here is our sample proportion. Right? So I've mentioned a few times now that notation is key, right? And that is definitely the case for these. So we want to pay attention to our notation and that we're getting everything kind of written down correctly. Okay, so now that we have a list of everything that we know, we're going to go through and we're going to check our conditions. Right, so checking our conditions. The sample is random and independent. We are told in our problem that it is a random sample. This first one we're going to assume that it is true unless we're told otherwise, because somewhere in our problem we're generally going to see the word random. Right, a large sample is at least 10 successes and at least 10 failures. Right? So what we're going to do here is we're going to multiply n times p and n times 1 minus p. Right? This n times p is going to give us the number of successes. And this n times 1 minus p is going to give us the number of failures. Right? So we're going to do 2 different multiplications to check this step. Again, going up to our list, we see our lowercase n is 100, and our plain p, plain lowercase p, is 20%, so 0.20. Right? So n times p is going to be 100 times 0.20. That gives us 20, which is greater than or equal to 10. So we have more than 10 successes. And then we're going to take 100 times 1 minus p. So 1 minus 0.20 is 100 times 0.80, which is 80, right? Which is also greater than or equal to 10. So we have at least 10 failures as well. So there is our condition 2. So condition 2, we're always doing a multiplication of those things. All right, condition 3 is that we have a large enough population. So our population is capital N. Capital N is all M&M candies. All right, and we want to make sure that that's greater than 10 times our sample size. So 10 times a sample size of 100 gives us 1,000. So then we ask ourselves, are there more than 1,000 M&M candies that exist? Yes, there are. So that third condition is held as well. Right? So these 3 conditions, again, are step 1. Okay. Now step 2, we find our normal distribution. So that means that we're going to find our standard error. Now, the first thing that we're going to put here, we're actually going to go up to the top part, and our P, right, our population proportion is going to be this first number that goes here. So that's going to be our 0.20. So our P that we used up top is going to be that number that we have there. Our standard error we're going to get from our formula. So we're going to plug this P into our formula. We get 0.20 times 1 minus 0.20 divided by our sample size is 100. Again, we want to practice putting this into our calculator all at once. Use parentheses as needed, or do your multiplication and division and then come back and take the square root. Again, whatever is easiest for you. And this gives us 0.04. Well, this 0.04 is the second number that's going to come up here. All right. So we're done with step 2. Step 1 is our condition. Step 2, find our standard error. That is going to be used for our normal distribution. All right, then step 3 says find your probability using StatCrunch. Again, we're going to use our stat calculator's normal, draw a sketch, and write the answer in a sentence. So I'm going to take my mean and my standard deviation, or standard error, from step 2 to label my curve here. So my mean was 20%, so 0.20. And then I'm going to add 0.4 as I go to the right. So I'm going to get 0.24, 0.28, 0.32. And then I'm going to go back here and I'm going to subtract 0.4 to go the other direction. 0.16, 0.12, 0.08. All right. Now I'm going to go all the way back to my original problem. My original problem says find the probability that our sample will contain 24% or more. Right? So that's our probability that we're looking for. So on my curve, I am going to draw myself a vertical line at 24%, so that's 0.24. Right? And then we're going to shade our area to the right, because we're asked for 24% or more in our question. Okay, so just like we did in section 6.2, we're going to shade in our curve as needed. All right, now we're going to go to StatCrunch. And in StatCrunch, what we're going to do, and I'm just going to kind of show what we're going to enter in StatCrunch up here. So we're going to enter that our mean is 0.20. Our standard deviation is our standard error, which is 0.04. Right? And then we're going to find our probability that p hat is greater than or equal to 0.24, because that's what we are asked. Right? And then we're going to hit the compute button, and it's going to spit out our answer right there. So this is kind of what we are entering in StatCrunch here to find step 3, where we're finding our probability. Right, so we put in our mean of 20%. Again, our mean of 20% is that value here. Our standard deviation, 4%, right, is that value that we see right there. And then we select the greater than or equal to, we type in 0.24, we select compute, and we get 0.159. So we are going to say the probability that our sample will have 24% or more orange candies is about, right, if we change this to a percent, we get 15.9%. So again, we choose to go to StatCrunch to finish this last part rather than going through and using our z-table as we did in section 6.2. But step 3 again is very similar to that process that we did in section 6.2. Again, but it's only one part of our problem. So there are definitely a lot of pieces, a lot of notation to keep track of, a lot of multiplication, some calculations to do, and then in the end we do want to use StatCrunch to help us finish this up. We'll go through and we'll do a bunch more examples, but this is working through using our central limit theorem from the beginning to the end in order to find a probability.